as a CTO at Vanhoutte. At Vanhoutte, we want to make people's life easier and more efficient by crafting tailored applications with a focus on user experience. So we do that with .NET, Azure, and the Power Platform. Next to that, I'm the founder of Your Azure Coach, where we give Azure trainings infuse people with our knowledge so they can confidently build, design, and run Azure solutions. Some of the board members, Tim and Wim, are also trained over there. And then I've been awarded as a Microsoft MVP, I think 4 years ago, if I'm not mistaken. Mostly active in the Azure integration space, Azure development space, but I have a broad interest in Azure, like Bicep, of course, like the session we had before is one of my favorites. So once you use it, you will never use ARM again. So very good session before. So this session is about API security. I get often in contact, of course, with that in an integration scenario. And I see that often, developers are struggling with it because, they don't get the concepts 100% right. And typically, developer don't want to blame them. But if it works, it's fine. But of course, it needs to work the right way and the secure way. And that's where I typically want to put my focus on. So we will start from a very early beginning, and hopefully we go from 0 to hero in this session. It's quite some demos in the session. If you're not into .NET, I think this session can be still very valuable. You can just skip some code snippets, but the concepts are very valuable because I apply these concepts also when I'm just using Azure API management. That's without any .NET or any other API security mechanism. So the concepts still remain very valuable, even if you're not into .NET itself. .NET in this case is just a vehicle to pass the message. So let's start from the very early beginning. What's the difference between authentication and authorization? Concepts, very basic concepts, but still often mixed amongst each other. So authentication is really the process to determine whether API consumers are who they claim to be. So the API consumers could be typically or users or applications. If it are users, and we talk about Azure AD, they typically authenticate themselves with username and password, preferably, of course, with MFA enabled and maybe some conditional access policies. Applications can typically authenticate through client ID, client secret or certificate or managed identity, which is preferred, of course, if you're working with Azure to Azure communication, because then you work completely secretless. Authorization is, of course, the process to determine what these API consumers are allowed to access. So there are 3 main options there. Just having an access control list, delegated permission, and application roles. And those are the 3 options I really want to focus on in this session. Of course, also maybe the most simple authorization is just no authorization, and we only allow authenticated people or authenticated applications. So that's what often happens, that it's just only authentication, but people don't think, is there additional authorization needed, yes or no? So I would like to give this session with a security metaphor, with a party. We are finally again allowed to go to parties. So perfect time to have this metaphor. So if you go to a party, we have a visitor, the person who wants to access the party. We have the ticket desk over here that validates the identity of the people who enter the party. And then, of course, we have here a steward who decides who can enter the party zone or who isn't allowed to do it. If we compare that with an API, our visitor is an application with user interaction. So the application that does stuff on behalf of the user. This session could be also with machine-to-machine communication, so with daemon services that don't have any user interaction. But I skipped that part of the session just to make it a little bit simpler and more condensed, because applications with user interactions are more and more common and a little bit more complex than without. So the ticket desk, I'm using in this case Azure AD, which acts as an identity and access management service. And then the steward here at the entrance of the API, in this case, is just the API access control component that we have inside our ASP.NET API. Could be even an API management instance if you would love to. So let's start immediately with the demo. I will create an app registration in Azure AD that represents the API, the party API. And I will do the same for the client application, the user application, I call it in this case. That also needs to be registered in Azure AD. And then I will just show you a very simple demo of the party API as it is right now. So I'm here into my Azure AD. So I can go to where are we, app registrations, and create a new app registration over here. Let's call it party API. Can be single tenant, and we can just register it like we have it right now. I want to use the latest version of the OAuth specifications of Azure AD. So that's why in the manifest file, I need to go here to the access token accepted version and put it to 2. This will make sure that we use the latest version. You only need to configure this on your server side, so on the API side. The clients will typically follow what the server here dictates. I will also need the client ID, so let me copy this already here in my notepad. Like this, we will use it later on. In the second tab, I will create another app registration. This time for my client app. So you call it the user client app. Again, single tenant, nothing special here to figure for the time being. And let me just copy the client ID. Voila. And we can use it over here. So next, I just want to show you a little bit the API for people who are interested. So it's just a very simple party API with a few operations. You just have an operation, a get operation to get into the entrance, to get into the bar, to get into the dance floor, the VIP zone, and these kind of things. And you always get the same class back, and so the same data set, which is just the date, where you are, and a random party status. So there are a few party statuses over here. So if I just run this API, for the people who are not really familiar with APIs, they are annotated here with Swagger. So I can just do here a git on the party/bar and just try it out. And we should get some information back, which says here, I'm currently at the bar singing at this moment in time. So just some random stuff. Let me switch to Postman, which is the most favorite and most popular tool to call APIs. So here I can do stuff like party/bar. And let me see, can I get into the bar? Yes, I'm singing again in the bar, crying now, laughing, seducing. But I could also go to the entrance if I would love to. And you see. So I can enter, of course, every separate aspect of the API right now, of the party zone, because there's no security on our API. So let's change that. The first thing I want to add is authentication with Azure AD. So if we do authentication on a party, the visitor typically goes with his identity card to the ticket desk. Then the ticket desk gives every authenticated person a badge, and with that badge you are allowed to enter the party zone if the steward here validates your badge and if it's all okay. That's how it goes in the party. So if we do it on the API, you need to make sure that here the application with user interaction, we need 2 things that need to be authenticated in this case. First of all, the user needs to authenticate, preferably a username, password, and MFA. And the application needs to authenticate. In my case, this will be with the client ID and client secret. And Azure AD will then, if the authentication works fine, return a JWT token. So a JSON Web Token, also referred to as an access token or a bearer token. And that access token is used to call the API. That's often where I see a mistake is often made. It might be that you also get an ID token back, but an ID token is used should be used in the application here itself to identify the person. But what you send to the backend API should always be your access token. And that's what the API will validate. It will validate the access token, and if the access token is fine, you will be allowed to access the party. Let's try to set up all the things we need to make sure that we can authenticate a web application, so the client application, with user interaction. So we will update our party API app registration and add an OAuth2 scope to it. We will configure a callback URI because that will be needed because we use the authorization code flow, which I will explain a little bit more in detail lately. We will create a client secret that we will need and configure delegated permissions. So quite some steps that need to be taken in order to make sure that we are ready to authenticate users. So let me go back to my app registration. Not sure here. Oh, this is still my API running. Yes. So here the party API app registration. I want to expose the API and add a scope over here. First thing they ask me to do is just give it an application ID URI. It's a very bad word. You can see it a little bit as a namespace that represents your API. So let me call this just HTTPS. Party API. You could use also your, how should I say it, your domain name could also be part over there. So, and now we need to add a scope. Typically, if you want user interaction, you need a scope to represent that. That scope can be any name, but there are two names that are very common. The one is user underscore impersonation, and the other one is access underscore as user. You could do whatever you want, of course, as a name, but these are the two most common ones. Then you need to say, okay, what admin consent do you want? It's admins only that I will do here. So not users. Users should not consent this. Only admins should consent that an application can access the party on behalf of the user. And if there's a user consent, I would change this on behalf of you, for example, to make it a little bit more personal. Let's enable this scope, of course, and let's click Save. So this is what I do on the party side, on the party API side, the server side thingy. The consumer of this API is this app registration, and that one also needs to be updated. First thing I need to do is add an redirect URI, which is needed in the authorization code flow, the auth flow. So here I add a redirect URI. I will use Postman as my web application, just to keep it very simple for everybody. So that's why I here use the common redirect URL of Postman. So just configure this one. If people try to use other redirect URLs that are not listed in this list, of course, Azure AD will not allow that. So that's also an additional security mechanism. Let me create a client secret over here. This is demo, so I can just do it like this. In reality, what you should do, in my opinion, is do this in an automated fashion and make sure that the value here of your client secrets gets stored automatically in Azure Key Vault, for example. Also make sure that you put over there in Key Vault in an automated way your expiry date, so you get notified before it gets expired. And because since recently the Azure portal doesn't allow you anymore to choose an infinite expiration. So I think within maybe 1.5 years, there will be lots of issues at customers where they just created them manually like this and forget that one day will expire. So we have our client's secret right now. I copied it, so that's all fine. And then I want to give here my application access to the party API. So we will give it added a permission. So here we can go to the API permission and granted the access as user permission on my party API. So remember here, my party API, the access as user. You see that this is a delegated permission, so it's on behalf of the signed in user. Okay, so that's a very important one. It's not a machine-to-machine situation, it's really a delegated permission. So let's add this. Voila. And let's just grant admin consent. I'm global administrator here in my test tenant, so that makes life easier for demos, of course. So this is here, all these kind of settings. This is where it typically goes wrong in many organizations because, yeah, we as normal developers, application architects, we don't get access to Azure AD, which is a good thing, of course. But then typically you need to say to the person, do you want to click there? Do you want to click there? And then they ask you, hey, how can I provide you with the client ID and client secret? And typically they put it in Teams, they put it on email. So all very poor practices. So make sure that you treat these credentials really as credentials and store them in Azure Key Vault or any other secure medium. So now I think we prepared everything to make sure that we can authenticate ourselves. Yeah. But let's have first a look on how the authentication works if you work with user interaction. So this is an OAuth flow. I took the screenshot here of the the Auth0 documentation, but this is just the documentation of any standard authorization code flow. What flow do you need to use? That really depends on your web application over here. Is it just a regular web application? Is it a single page application? Depending on the type over there, you need to choose another flow. But what I just want to make you sure, you see here all these details, and probably you don't need to know them right now. The most important thing is that your API, it doesn't care which flow you're using, which OAuth flow you're using. The only thing that your API wants is a request with an access token. And your API will only focus on that access token, will validate it, and if it's fine, you are allowed to enter the API. If it's not found, you will not be authenticated. So all the rest is the responsibility of the web application, and depending on the type, the flow will be a little bit different. Here we will use a regular web application with the authorization code flow, which means that we need to provide a redirect URL over here where our web application will need to listen on, and the Azure AD tenant will return the authorization code flow once somebody is authenticated. And with that authorization code, we can ask a token, an access token, to the Azure AD tenant. And then, of course, we can use that access token to call the API. So that's very important. Your API doesn't care about all of this. It only needs to validate and check the access token. Let's try to do that right now. Let's get the access token for our user with our Postman app. So let me just have a look. Yeah. I go to Postman over here. You see we don't have authorization right now. See also here that we have 6 headers right now. After my authorization, you should have 7. So I will use OAuth2 as an authorization mechanism. Go a little bit down here. The grant type is authorization code, so that's fine. The callback URL is already filled in, so that's good. And then we need to use to have the authorization endpoint and the token endpoint of Azure AD. Where can you find this? Apologies, this is not the one. Over here, we go to our party API, and on the overview tab, you have here endpoints. We have all the endpoints over here. Remember that we selected the V2. So here we have the authorized endpoints and here the token endpoints. They are already filled in over here, so I don't need to explicitly copy paste them again. My client ID, I can just replace it over here. So I need to have the new client ID like this, and the client secrets also needs to be provided. And my scope, let's just make sure that we copy paste the scope right. So if I go to expose an API, we have here our scope. So let me copy this and put it over here and get hopefully an access token. Yeah, I didn't need to log in. So let me maybe clear my cookies first and do it again. Yeah, so now I need to log in so that you at least you see that there is that user experience. So azurecoach.com. Yes, provide my passwords. Not sure if I will need, no MFA this time. That's good. Now I can inspect my token and say here, use the token. When I click on use the token, you will see that we now have an additional HTTP header, and that's the authorization header, which contains the value better, then a space, and then the complete token. So the complete token, this is a signed token, a JSON web token, JWT, JOT token. There are different names for that. You can inspect that on this website, just jwt.ms. You copy paste it over here, and you see actually what the token is about. So it contains typically 3 parts, with the dot in between over here. So this is the most important part. These are all the claims, claims about the application, claims about the user. There's a signature part, and there's some information in the header about the signature. So what are the most important claims? The first one is the audience. The audience is for who is this token, this access token, who needs to receive this. And actually, this should be the client ID of our API. So this is the 673E. So indeed, the 673E over here is the client ID of our API. Next to that, we have the AZP claim. That's the client ID of the calling application, of the client's application. So this is the 2F56. So here the 2F56, that's the client ID. And of course, you see my name. This is my object ID. So this is my unique ID in Azure Active Directory. And you see also that we have the scope over here, the access as user scope that has been allowed by me, so has been consented by me. Right? So this should be fine. So now we have authenticated our user inside our application, and we got back an access token. Now we want to enable and enforce authentication on our API. So what should we have over there? What does that authentication need to do? Well, first of all, we need to validate the signature of the access token. If the signature is not valid anymore, it should be refused. Also, the lifetime is important. So these tokens are typically around 1 hour valid. So if a token is expired, it should be denied. You need to make sure that the audience is correct. The audience should be the client ID of our API. Otherwise, you can just create your own tokens against another audience and you just get in. And of course, the issuer should be correct. We should make sure that those tokens are signed and originating from our own Azure AD tenant and not from another one. Otherwise, you can just send whatever token. So that's important. These are the minimal requirements to do authentication on your API. So let's do that. Let's make sure that we globally enforce authentication on our API. And let's also override that for another operation. So let me go to my API over here and add some stuff. If you're not into .NET, no worries. It's not that important, the details then, but you will just be able to follow by the explanation. So the first thing, by default, we have here the app.use authorization in the configure and the startup file. So I need to add here app.use authentication. That's the first thing we need to do. Second thing I want to do is make sure to tell here, we paste this one to make sure that we don't need too much typing over here, but we say we will add authentication. Yeah, we will use the default bearer scheme. That means, okay, we expect an authorization header with a bearer space and then the JOT token. And this is here a very nice operation that we get from the Microsoft.identity.web class that says, okay, we will add here Azure AD security for a web API. And the configuration, you can find it in the app settings in the Azure AD setting. In the Azure AD, section. If you go to our app settings, we should add section over there. It says, okay, what's our tenant ID and our client ID? So the client ID is the client ID of our party API. Let's do it like this. And the tenant ID, I should be able to copy it from the Azure portal on the overview tab. Where is it here? The tenant ID, like that. Voila, let's save that. And now there are actually two ways to enforce authentication. The first one is just to say, let's go to the party controller, and here on the highest level of the party controller, we can add an attribute that says authorize. The problem with that, I don't like that approach, because if somebody adds here a new controller and they forget to add that attribute, we have an unsecured endpoint and unsecured controller. So I really like to enforce that centrally in my startup file. And this is how we can do it. Again, don't mind the syntax too much if you're not into that. But where are we here? On the add controllers, we say, okay, we will add the controllers, but we will add an authorization filter. And what will we do in that authorization filter? We will create a policy, an authorization policy. And currently the policy only requires here an authenticated user. So from an authorization perspective, what do we enforce? We only enforce authentication. That's the only thing we do right now. So that's the lowest form of authorization, is just making sure enforcing authentication. Once you're in, once you're authenticated, so you are a user of our Azure AD tenant, you have full access to our API. That's what we do right now. Let me run this API. Voila. Call it, and hopefully I should get in, because I have already here my authorization. If I would call this without an authorization header, so just do a get without it, you see I'm unauthorized, I don't get in. Sometimes you get some more information here, but here it just says better right now. So yeah, this is fine. Maybe I can just show you that there is really validation. If I go here to the app settings and I say, okay, my client ID is something else, like this, then normally I should not be allowed anymore here, because this one contains a JOT token here, which has a different audience than what my API is currently expecting. So now I'm unauthorized because it's not having the audience that is expected. This is just to show you that there is security. But yeah, if you go to a party, you should be able to enter the entrance without authentication, of course. It's only for the party zone that you need to be there. So what we can do over here on the entrance, I don't want security at all. I want everybody to be able to access this. So I can do this by decorating this by allow anonymous. So this will override the global enforcement and will make sure that everybody should be able to get into the entrance. Let's verify this, run my API again. Yeah, this guy is authenticated. It has the authorization enabled. So if I do a send, I'm getting in. But here, this one is not authenticated. And now we get in. And so you see, we are at the entrance, dancing, sleeping, laughing. If I go to something else, for example, the dance floor, I'm not getting in because I'm not authenticated right now. I don't have an authorization header. I don't send an access token. You see, this is a way to make sure that one of the methods, one of the operations is not enforcing the authentication. Let's get back to the slides. The next thing I want to do is I want to add explicit authorization. And the first type of authorization is the access control list. So if you compare this with the party scenario, it is really working with the guest list. So the ticket desk gives every authenticated user a badge. And here the steward checks, of course, is the badge valid? That's the authentication part. And is your name on the guest list? If you're on the list, you can get in. If you're not, you will not be allowed. So that's the same what we can do for APIs. So there a JOT token is returned. And remember, in the JOT token, we have the client ID of the application that calls us. That's the ASP claim, if you still remember that one. So we could here contain at our API, we could have in the configuration a list of client IDs that we allow, and those applications are allowed to call our API and no other application. So this access control list, you should only do this with application level security. Never do that with user interaction because that would be too much. There are other ways to do it. Just do this to restrict the applications that can call your API. So what are the typical use cases? We can only do this if we talk about a limited number of applications. So if you know this API, for example, can only be consumed by 1 or 2 or 3 applications. If you constantly need to update your configuration file, probably you didn't use the right pattern. So access control list is maybe not for you. A very common pattern there is if your API is behind API management, it should only allow the API management as a consuming application. So that's a very good one. With this authorization, with this form of authorization, you do not consider the user context at all. So you just say application 1 and 2 are allowed. And as long as the user is authenticated so known in our Azure AD tenant, it is fine. This kind of application, this kind of authorization can of course only be done on the global API level. It's not really a fine-grained way of doing authorization. Let's make sure that we can implement this in our demo environment on the party API. So we can get back to my party API over here and first add some configuration over here. Again, let me copy paste this to go a little bit quicker. So here I can just add a custom entry in my configuration file, access control lists, and I just provide here an array of client IDs, application client IDs that are allowed. So I can here allow my user clients application if I want to. Voila, and maybe another one like this. Only users that are authenticated through this application and through this, of course, non-existing application will be allowed. Of course, now I need to implement the logic, and how I can do this. Well, we can here, not here, sorry, but here in our startup file, remember that we had our authorization policy builder. Currently, we only require authenticated users, but we can add another validation. And the validation that we will do is we will make sure that we will only allow requests where the ASP claim is present. And its value should be one of these values that are in our access control list. So the ASP claim is the one that represents our client application. If that claim is on our list, on our guest list, they are allowed to call the API. Otherwise, we will just block them. So let's give that a try. Normally, this should still work. I should still be able to call because I'm authenticated and I'm calling from the right application. This one will not work, of course, still, because this one is not authenticated at all. Let me just change here the configuration and let's say maybe this this client ID is not allowed anymore. So let's change it to another one. Now I will not be able, hopefully not be able anymore to call my API because the ASP claim in this token here is not allowed anymore. It's not on the guest list. This is not what I'm expecting. Let me have a look if I did something wrong over here. Maybe this, not sure if it's was updated. So let's give it a second try. It still works because I'm calling the entrance. And remember, there's no security on the entrance. So if I go now to the dance floor, I hopefully, I'm forbidden now because I'm not on the list. You see, if I'm again back on the guest list, I think it was a 2 that I removed. If I'm back on the guest list over here, I'm hopefully also able again to call the API. Yes, so that works fine. So we have now our access control list easily implemented with Azure AD on our API. Next thing you can do, it's a little bit more complex, but of course a little bit better, is work with application roles. That's a concept in Azure AD that allows you to configure role-based access control. So the first thing I will do, again, the ticket desk will give every authenticated user a badge with a certain color code. You will have green badges and blue badges. The steward will only allow people with a green or a blue badge. But there's also a steward here in the VIP room. And in order to enter the VIP room, you need to have a blue badge. With a green badge, you will not be allowed to enter the VIP. This is the concept of application roles, where in Azure AD, we assign a certain role to the user. Then depending on what role the user has in Azure AD, a different claim, a role claim will be added to the job token. And this is where we can validate on. In our API, we will have global enforcement that we only allow users with a regular or a VIP role. But here we will have an additional steward, so an additional security mechanism to make sure that here we only allow people, or in this case, API requests that have a job token with the VIP role claim inside of it. So for which use cases would you use that? This is very good if you have a potential high number of applications or users that want to consume the API. The good thing of that application roles is that it can be used for both applications, so for machine-to-machine communication, but also for users that are logged into an application. So it's a very powerful mechanism. In this case, authorization can happen on multiple levels. You can have global enforcement, but then to call certain operations, you need to be an administrator or an operator. So you can really go fine-grained on multiple levels of your API. So this is the perfect use case if your requirements fit into a role-based access control model, which is very often the case. So let's try to implement this with Azure AD on our API. So we will define application roles, assign the role to a user, inspect the token, and then do the enforcement of that on our API. So here, let me go to my scenario again and to the party API. And here we can configure the application roles over here. In the past, you used to do this in the manifest, which was really a cumbersome experience. But luckily, since I think half a year or maybe a year even, time goes fast, you can do it here in the UI. Of course, you should do this all automatically. It's not possible yet with Bicep, but I think the extensibility is coming up, so that would be nice if we could also, start to automate our Azure AD stuff with Bicep. So here the display name of the role will be a regular user. As a member type, we will use the both. So both applications or users can have this role assigned. The value inside the claim will be just regular like this. And then the description can be access the party as a regular user. Voilà. Let's create a second role for the VIP user. Again, this could be a user or an application. The value in the claim will be just VIP. And here we could say something like access the party as a VIP user. Voilà. And save this. So now I want to assign the regular user role to my own user. You cannot do that on your app registration because an app registration is just a definition of your application. If you want to assign roles, you need to go to the underlying enterprise application. Yeah, I know Azure AD and user friendliness and good naming conventions, it doesn't go hand in hand. But if you click through here in the managed application in local directory, you will navigate to the enterprise application that is linked to your app registration. And that's actually the implementation of that app registration in your own tenant. So if you would have a multi-tenant scenario, you have one app registration and then an enterprise application in every single tenant where that application is active. You can go here to users and groups and just say, okay, let's give myself here, this one, a certain role, and this will be the regular user role. Voilà. Select, assign, and do it like this. I could request right now a new token, but I will wait a little bit. I will first configure my API, and then we can change my token. So if I go to my startup file over here, I need to remove this one, the required claim. This was for the authorization via the access control list. Now I can do it even more simple, and I can say the dot require role over here, and I can say which role do you need to have? One of the roles in order to enter the API. So for me, only people with a regular role or a VIP role, sorry, are allowed to enter my API. All the rest is not allowed. So let's run this thing. Call the API still with our old token, and I hope I'm not allowed anymore because My old token does not have yet the role configured because the token is not refreshed on every call. It just cached into my application. So if I go to here and say, give me a new access token. Yep, a new token is requested to Azure AD. I will use it, call the API, and now I'm in. Why am I in? Let me have a look at my, this can be removed, at my access token, copy paste it over here. And you see now, because I configured my user with a regular role, you see here that the role has been added as an explicit claim into my job token. So that's how the API knows that I'm a regular user. So this is of course fantastic because all your role assignments can be done in Azure AD and you don't need to change anything on your implementation side. Remember that I wanted to have the VIP role, that role needs to be there if you want to access the VIP. So in order to enforce that one, you can go here to the get into the VIP operation and can do something like authorize, and then I think we have roles equals VIP like this. This is an attribute that will enforce that only people or API calls with the role claim VIP in the job token will be allowed to call the API. So let's do this again. Am I still allowed to go to the dance floor? Probably yes. But if I want to go to the VIP, I will not be allowed. No more information here. So I get an 403 here, forbidden, I'm not allowed. That's positive news because I'm not a VIP, so I should not be able to enter that one. Okay, then the last one is authorization with delegated permissions. And that's probably the most complicated one. So here we need to consider that there is a general party zone, but then inside the party zone, you have a few private parties because there are probably birthdays going on from John, Mike, and Dan in this case. So my visitor wants to access the party of John, the private party. So he asks actually consent to John. So John is the resource owner, the owner of the party. And John says, yes, it's fine. He confirms the paper and says, yes, Toon, you are allowed to access my private party. So I go to the ticket desk with my own ID card and of course with the consent form of John. And the ticket desk gives me a badge where there is a single line here that indicates that John has given consent to enter his private party. And of course, with that consent, I am allowed to access John's party, but not Mike's or Dan's. So how does it work in reality? We ask consent as an application. We ask consent to the resource owner. The Azure AD token will, in this case, we will ask consent for two scopes, one for the access as user, and we will create a new scope, the access private party scope. And then if you want to enter the private party, you will need to have the scope access private party in your token. And of course, you will only be allowed to access the party or the data from the person who owns the data. So if Mike gave consent, I'm allowed to enter here and not there. So this is actually the reason why OAuth 2 was invented back in the days. A good example of such kind of delegation is if you go to a photo printing service, or where you can create gifts with pictures on it, like a t-shirt with a picture or nice other things. What you could often do there is give that application access on your Google Drive or maybe on your OneDrive to find all the pictures that you have over there. So that's a real delegation permission where you give the application consent to access your OneDrive, your data. So that's application can only access your data and of course not the other data. So that's very important. The consent is always linked to a person and the resource owner in this case. That's very important. So when can you use those delegated permissions? That's always when a user is logged in. So you cannot use this in the machine-to-machine context. Make sure you have a real delegation scenario. access really something on behalf of. This is typically used in SaaS applications is often that are multi-tenant, where you want to access resources on behalf of. So if we want to implement this in the demo, we need to add a scope. We will ask again a new access token, and then we'll make sure that we have a validation, a global validation again, and an operation specific one. So final part of the demo over here. Let me go to my Azure AD instance, go to the party API and add a new scope. Over here, so we had already the access as user, and now I will say add the access private party scope. Who can consent? In my case, I really want to consent the user. The user needs to consent that they are allowed to access my party. So we need to give a description again. It allows the application to access the private party, and the user consents instead of the access the private party. I would like to make it the to access your private party, and maybe just put demo between brackets so you really see that this is what should be added then to the user. All right, so this is all we need to do. Now we need to update our application because we also need to ask consent for this one. So instead of having here, remember on the authorization tab, we had the scope access as user scope. We need to add another one. So we can just add a space over here and add the second one, the access private party scope. Now I can request a new token. Okay, that's not good. Did I do something wrong? Let me go to here. So it is enables admins and users. Yeah. Right. Yeah, probably there was a wrong copy paste or something like that. So now they ask me, okay, this application wants to access the party on behalf of you. See here, even with the demo. Normally users should not have this one, a consent on behalf of your organization. This is because I'm a global admin. So I can just accept over here, proceed, copy paste it, and use the token so it gets updated here in my authorization header. If I now go to the token inspection, you should see that everything is the same except here the scope. We have an added a new scope, the access private party scope. So we can access the private party, and whose private party? Well, here Toon Vanhoutte. So we know that his unique ID in Azure AD. So we need to validate on that. So again, the same principle like we had before. Remember in the startup file, and the last check that we had was require a role, and now we need to require that the access as user claim is there. This is a little bit more complex than you might expect. So let me just copy paste here the whole snippet that we need for that. So the claims, it's a standard claim, the scope claim, so it gets mapped here to this standard claim. So I just split it with the space in between because there are multiple claims. What I just say is one of these claims is the access as user claim, then it's fine. Otherwise, we will not allow the user to access the API. Of course, if you want to go to the private party, you need to have the additional claim. So if somebody wants to go to the private party, my apologies here, we have the operation get into the private party. We can enforce this by doing this. Let me also just copy paste it. That we verify here that the user has accepted any scope. So to access this, you need to have consented actually, the access private party scope. Yeah. And of course, inside our code base, we can know who the user is, because if you go here to the database, to your data store, to whatever store you have, you need to make sure that you go to the data of that user to the party of that user and not to another user. So you can find here the user via this little syntax. So if I now try to access the private party, I will be able here, because I have consented. This is the VIP, so sorry, I'm still forbidden over there. If I go to the private party, like this, I'm in, and you see it's the private party of Toon Vanhoutte and not of somebody else. So that's very important, that user context should be there. All right, so that's a summary of my session. So we had a look at authentication versus authorization. So we explained how you can enforce authentication on your APIs. And then, of course, 3 different ways to do authorization. One with the guest list, one with the role-based access control, and one with a real delegation scenario where you have really the on behalf of flow. You could read all of this and even other scenarios on my blog series, API Security for Dummies. And everything is also on my GitHub repo. So also over there, you can find all the steps that you need to do to simulate this. So it took me a while in the past to figure out how it all works. So I'm very happy to share it today and also before already with the community. So thanks a lot. Maybe let me have a look if there are any questions.
I didn't see any directly, Toon, at the moment.
Alrighty.
Does anybody have a question for Toon? You can just unmute and ask it yourself if you want. But I must say it was quite clear.